we are looking here at the GitHub repo of Miguel de Casa. This particular project, Redis Sharp, which is .NET binding to the Redis and memory cache. This particular repo is special because it's the one of the few .NET projects out there that works seamlessly both in Mono and in Windows Visual Studio. So I have cloned this repo in here. So I have cloned it. At the same time, this is also a shared folder into my Windows and as a virtual guest OS in VirtualBox. So that path there is also this one. Okay. So my Ubuntu machine and my Windows machine is sharing this folder. As a proof, if I create a file ABC here, it should if we refresh this, it should appear here. This is the file, and if I delete the file, then if we refresh this one, and the file is gone. So this is a shared folder. Now we can build this, because this is a .NET project. We can build this using Visual Studio, which is I use here is the 2010, and it builds fine. No problem about that. The interesting thing here is here I will be running a Docker Mono instance. So under this path, Docker run it using the current path and map it to stuff in a Mono instance and give me a bash shell. So now we are in a Mono instance as a Docker container, and if we go to stuff, we can see the same projects there. So let's try to find the presence of .exe files. And indeed we have this compiled version. We can clean this by using the command xbuild then target clean. So if we try to find another file, it is gone. You can ignore this one. Okay, so it is gone, and inside the container, what's happening here inside the container is also reflected here in the Windows location, because it's a shared folder. And if we rebuild again, just type build there, and we have the executable there. As you know, this container is an Ubuntu Debian. So we are inside a Debian Linux. This is a Linux machine here, but through Mono language, it can create an executable that can both be run in Linux and in the Windows. For example, the executable that we just compiled here. Okay, let me clean this again. There. So if we go here, it's gone. But if we rebuild it, and if we refresh this folder, maybe it's here. Sorry. Okay, let's clean again. So it's clean and rebuild. And it's there. So The source code of this program is here. If we open the main test with C#, so it creates a Redis connection to this IP address, which corresponds to my IP address here. This one. However, right now no Redis instance is running in my local machine, so let us again create another Redis instance here, another Docker container. Docker run so in order to expose the Redis to the host, we pass a port 6379 in the host and map to 6379 into the container. There. So if in summary, we now have two Docker containers. This one is a Redis and the mono, which is this one handling the C# compilation. We can monitor Redis through Redis CLI monitor, and now the Redis library in-memory cache is waiting for keys to be set there. If, for example, we can run this executable here by double-clicking it, and take note that I compiled that in a Linux environment and I run it in a Windows environment. Let me try to double-click this, and as you can see, it was able to communicate to Redis. We can also run the same executable in Linux here. The way to run that is to prefix it with mono, just like when you run Java program, you put Java. So you put mono, then give it the executable, exe. So this is how you run Windows executable in a Linux under the mono runtime. And as you can see, it's also writing to the Redis successfully. Let's repeat that because it was a little bit faster. There. So either this one, and in fact we can copy the executable and its dependent library, the DLL, because that is the only one that it needs here, and move it to entirely new location, like in this folder there. So this is the main program, and it needs this driver to talk to Redis. So if you double click that, and it still runs. Of course, if this library is missing, we can simulate that by renaming the DLL. So basically it's missing now, and if you run the program, it will crash because it could not find the library. So some of the this is one of the good things in the mono unification of executables. The closest they can see that is more or less like this one is in Java world, where we can run programs both in Windows and in Linux in Java. Java is not natively compiled, whereas this one is more faster because it is natively compiled x86 machine code. I think the other one also approaching to this kind of interrupt between systems is Golang, because a Golang can run both in Windows and Linux, but Golang is different because you need to cross compile first for the particular target. So you can cross compile it to run on Windows, but that will only run in Windows. Then if you cross compile it for Linux, then it will run again in Linux, because it does not rely on a runtime that exists in those environments. So there is that step. It is a dedicated target. You need to cross compile it there. However, for the mono or C# world, the runtime exists to prepare, and for the executable to run there, there's no need to do such cross compilation. If the platform mono or C# is in the target environment, then you can achieve cross systems execution, just as this one. That's all for this one. Thank you.